Okay, so for question 4, this is a binomial expansion one, which is good because we can use the formula in the formula book, so you don't need to like memorize anything for this. So finding the first three terms of that in ascending powers of x. Okay, so for this one, what you want to do first is like rearrange it so that it's in the form 1 plus x to the power of n, right? Do anything? No. No. Okay, I don't. Yeah. So, what was I doing? This. I'll write it here. So for this one, 1 over the square root of 4 minus x. So we know that anything that's like square root or whatever, that's the same as just doing whatever to the power of a half. So this is the same as 1 over 4 minus x to the power of a half. And then if you're doing like 1 over something, then that's the same as just doing like that, how do I say it? Like that thing to the power of minus 1. And then since there's like a half here, you just do that times the minus 1. So that to the power of minus a half. Okay, so we have this. We need to get it so that it's a 1 though. So to do that, you'd have to take a 4 out of like this whole thing. So if you do that, you'd get 4 times 1 minus... Oh, yeah, that's a bracket. I don't know why it looks like a C. Yeah, so 4 times 1 minus a quarter x. And then that's the whole thing to the power minus a half. And then because you're like timesing it, then you can just also put the power like there, right, to separate it. So this is the same as 4 to the power minus a half times 1 minus 1 over 4 x to the power minus a half. Okay, so now we have it so that like this bit, that's what we were like trying to get, right, is in the form like 1 plus something to the power something. It doesn't matter that it's like a minus over there, but in here it says plus x because like the x can be like anything. Oh yeah, anything as long as it's like less than minus 1, the modulus of it, which it is because we have 1 over 4. Okay, so if we expand out this bit, so what we're saying is our x is equal to minus 1 over 4x, and n is minus a half. So wherever you see x or n in this formula, just replace it with minus 1 over 4x and minus a half. So that's gonna be 1 plus n times x. So that's that. And then n minus 1 over 2 x squared. So that's minus a half, and then minus a half minus 1, which is minus 3 over 2. The whole thing over 2 times 1 over that squared. Oh, I think that's going to a little bit, but whatever. Okay. So if you like times all these out, so you get 1, and then you'd get plus 1 over 8x. And then for this one, give me a second, I'm going to use my calculator. Okay. Yeah, for that you'd get plus 3 over 128x squared. Okay, so that's when you expand out this bit, but then you also have to remember that we have the whole thing times by 4 to the power of minus a half, which is the same as just a half. Is that right? Yeah, I think so. Okay, so what you want to do is a half times this whole thing. I'm not going to write all that, but just pretend it's in brackets. So if you did that, you'd get a half plus 1 over 16x plus what's that, 3 over 256x squared. So that should be the answer. Wait. That's all that question. Okay. Here. Yeah, a half, 1 over 16, doing that. Yep. Let me just... there. Yeah, so that's that bit. Okay, then part B, without evaluating it, state giving a reason which of the 3 values of x should not be used. So the expansion can be used to find an approximation to that. The possible values are that and that. Okay, so for this one, so you know, the condition for like this expansion is that the modulus of x has to be less than 1, right? So our x was minus 1 over 4. So hold on, let me just do this. So modulus of that has to be less than 1. Which is just like if you get rid of like the minus 1 and stuff, right? Or sorry, not get rid of the minus 1. So if you like actually apply the modulus bit, right? So making this like positive, you get that 1 over 4x has to be less than 1. And then move the 4 over, so times it by 4. So our like condition thingy, rather than x being less than minus 1, is x has to be less than 4, right? Okay, so going back to here, they used x's, I guess keep the modulus bit as well, right, in case they use minuses. So this is, what's it, so they used x is minus 14, x is 2, and x is minus a half. So if you compare all of the x values they used, no, sure, I'll just stay here, to, like, x having to be less than 4. Where'd it go? Here. So, yeah, so if you do that, the modulus of it, a half is less than 4, so that's fine. 2 is less than 4, so that's fine. But the modulus of minus 14 is 14, which is more than 4, right? So this one's not okay. So, is it I? Yeah. So for this one, you'd have to say x is equal to minus 14, because I guess because like the modulus of x has to be less than 4, and 14 isn't less than 4. Yeah, I think that's fine. I'll check that after I do the second part too. State giving a reason which of the 3 values of x would lead to the most accurate approximation of root 2. Okay, for this one, you get a more accurate value the smaller your x value is, right? So between 2 and minus a half, the smaller one is minus a half, so x is equal to minus a half because it's the smallest. So smaller than 2. I think that's what it is. Yeah, okay, closest to 0, smallest, yeah, same thing. But I guess put closest to 0. Yeah. And then this bit, the expansion is not valid for x is more than 4. So, yeah,